So in this lesson, I'm going to show you the last way to determine the enthalpy change for a reaction, and that's by using Hess's law. Now, Hess's law tells us that if a reaction is carried out in a series of steps, your change in enthalpy for the overall reaction is simply going to be the sum of the enthalpy changes for each individual step. Okay, so if we add reactions together to get our final reaction, all we have to do is add our enthalpies together. So let's look at an example to apply this. So I have a reaction of carbon with oxygen producing carbon monoxide, and the two steps that are required for this reaction to occur are shown below. Now, I need these two reactions to add together in order to get me that reaction up above. And if you notice right now, the carbon dioxides aren't supposed to be there, but they don't cancel out because they need to be on opposite sides in order for them to cancel out. And so that brings up a couple of rules that I need to add on for Hess's law. The first one is that in order to flip a reaction, okay, so for example, if I want to flip that bottom reaction, I have to multiply the enthalpy change by -1. So instead of being -283, it would be +283. And the second rule, which we're not going to use for this example, but you definitely will use for future problems, is that if you want to multiply an entire reaction by an integer, let's say, for example, instead of just carbon, I had 2 carbons, right? 2 moles of carbon. Well, what I would do is I would multiply the entire reaction by 2, and I would also multiply the enthalpy change by 2 as well. So it would be -393.5 times 2. And then you simply just, once you've manipulated those individual reactions, you're simply going to sum your reactions together, and that gives you the enthalpy change for that overall reaction. So for this problem, as I noted, I want the carbon monoxide to be on the product side and the carbon dioxide to be on the reactant side so that it'll cancel out with the carbon dioxide in the reaction above. So I'm going to multiply that entire reaction by -1. And so what that creates, I'm going to rewrite it below. I still have my original reaction above. I haven't changed that enthalpy at all, but I flipped the bottom reaction. So it's going to be carbon dioxide producing oxygen gas and carbon monoxide. And notice I also multiplied my enthalpy change by -1, so now it's 283.0. Now, if I add these reactions together, okay, my carbon dioxides will cancel, and I'll end up with the reaction that I wanted originally. Also notice one thing that I didn't mention, I have an oxygen up above, 1 mole of oxygen, and then half a mole on the other side. Well, since it's 1 mole and half a mole, I can actually eliminate the half mole and simply make the 1 mole of oxygen in the reaction above just 1/2 oxygen. And so that gives me the reaction that I wanted. Carbon plus half a mole of oxygen produces carbon monoxide. And now all I need to do is I need to add those enthalpies together, and that gives me my enthalpy of reaction, which is -110.5 kilojoules.